Today, we are strapping in for one of the most complex, high-stakes engineering environments on the planet, the fabrication of massive oil and gas drilling rigs.
Right.
When you look at one of these enormous structures, maybe a semi-submersible or a drill ship, you aren't just looking at steel and mechanics.
Not all.
You are looking at a product where the quality, the safety, and the environmental stewardship must be, well, they have to be nearly perfect. This isn't just heavy industry. This is something else entirely.
It's the apex of integrated management. That's the core distinction, and it's critical for you to understand this. We are not talking about simple checklists or some inspection at the end of the process.
Right.
The framework that allows this construction to happen safely anywhere in the world is what the sources call an integrated management system, or IMS.
An IMS.
Yes, and this system deliberately fuses the major global standards. Quality, which is ISO 9001 and the industry's own API Q1, environment, so ISO 14001, and then occupational health and safety, which is ISO 4501. They're all bundled into one mandatory cohesive unit.
So our mission for this deep dive, then, is to map those specific layers of precaution. We're going from the corporate boardroom strategy all the way down to the daily welding zone procedures.
All the way.
The things that guarantee zero harm. We want to show you how a yard satisfies the expectations of major global operators, like a Shell or a BP, and, just as important, how they meet the demands of the ESG-focused investment community.
Exactly.
Okay, so let's unpack this enormous process. Rig construction moves through 8 major phases, and we need to see how safety and sustainability are fundamentally baked into the blueprint.
Right, from the very beginning.
Starting at the design desk.
It starts at phase 1, planning and design. This is where technical risk analysis really meets corporate responsibility. ESG begins right here with mandatory technical reviews.
What kind of reviews are we talking about?
Well, the sources mandate checks like HSE, that's hazard identification, which is a structured analysis to spot potential accidents before they ever leave the drawing board.
I see.
You also have SIL, the safety integrity level analysis, and OLOP, which is layer of protection analysis.
So it's not just brainstorming what could go wrong, it's actually quantifying the systems in place to prevent those things from happening.
Precisely. You are building in resilience from day one. Environmentally, an initial EIA, an environmental impact assessment, is created right away.
And on the social side.
Socially, the commitment is to stakeholder engagement with any affected communities and absolutely ironclad anti-corruption measures that are enforced during the entire bidding and contracting process.
So since the design phase is so meticulous, does that same level of planning carry over to when they start handling the raw materials? Phase 2, material preparation?
Absolutely. The risks just change in nature. Here, EHS immediately focuses on storage safety. We're talking fire and explosion prevention for materials and mandatory training for operating heavy equipment like forklifts.
And the social component you mentioned.
That's critical here, too. CSR demands screening the entire supply chain to eliminate materials sourced from conflict minerals or associated with human rights violations. You have to prove where every pound of steel and every component came from.
Okay, here's where it gets really granular, moving into the core fabrication risks. Phases 3, 4, and 5. When we're cutting and machining components in phase 3, the immediate threat is often noise, dust, and waste.
That's right. EHS requires dedicated engineering controls over high noise levels and metal dust generation, that dust being a serious respiratory hazard. Plus, there's an intense focus on carefully managing the cooling wastewater used in those processes, making sure it doesn't pollute.
Then you hit the absolute heart of heavy industry. Phase 4, welding and assembly. This is high-risk hot work across, I imagine, multiple elevations.
The precautions here are incredibly stringent because the risk of fire and even catastrophic structural failure is constant. We're talking strict control over welding fumes and light isolating zones.
And quality control.
And verifying quality through 100% NDT non-destructive testing.
100%. Not just a spot check.
No, this isn't a spot check. This means radiographic testing, ultrasonic testing, and magnetic particle inspection on every single critical weld to ensure there are 0 flaws. The quality standard is the safety standard here.
And phase 5 is coating and painting. This is the stage that ensures the rig doesn't just corrode away in the marine environment.
Right, using heavy epoxy and polyurethane systems. The EHS challenge here is acute, specifically controlling VOCs or volatile organic compounds to prevent worker inhalation.
So it's a health and an environmental issue.
Exactly. These systems are inherently hazardous, so proper management of the resulting paint waste, which is hazardous waste, is completely non-negotiable.
As fabrication progresses, the risk profile must shift. Phase 6, equipment and systems installation.
It does. The danger moves from, say, physical trauma and fire to electrical hazards and arc flash incidents. Environmentally, the focus shifts to reducing hydraulic oil loss and ensuring that insulating materials are all PCB-free.
And the people doing this work.
Well, the CSR element here is crucial. Only trained, competent, and fully certified personnel are allowed to handle these complex critical systems.
Then phase 7 is testing factory acceptance testing and site acceptance testing. This feels like the grand rehearsal before opening night.
It is, and safety is tested explicitly. Controls include mandatory emergency scenario drills under observed conditions. Quality has to adhere to the most stringent standards like APIRP and DNV rules.
And socially.
Socially, CSR requires transparent and full reporting of all test results and any failures directly to the customer. No hiding anything.
Finally, phase 8, transport and installation. Moving these massive structures must be a feat in itself.
It is. The EHS priority is absolutely safe, supervised heavy lifting and triple heavy transport, tracked through documented safe system of execution plans, or SSE.
And the environmental focus shifts offshore.
Yes, exactly. It concentrates on minimizing impact on marine life. This is where things like reducing underwater noise during the delicate installation process become mandatory requirements.
So if we connect all of this to the bigger picture, you can see why that integrated management system is so essential.
These 8 detailed phases have to be overlaid by 4 comprehensive, overarching management layers that dictate everything.
We've seen the process step by step. Now let's zoom out to that 4-layered management system. Where does accountability start?
It starts at layer 1, governance. This sets the strategic and ethical tone. Key policies include a formal zero-harm declaration, strict human rights policies, and comprehensive anti-bribery and corruption frameworks.
And the accountability is tiered.
Intensely tiered. The CEO approves the strategic key performance indicators.
Can you give us an example of what those CEO-level strategic KPIs actually look like?
Certainly. They might set targets for safety, like the lost time injury frequency or LTI, to be less than or equal to 0.5.
And what does that mean in real terms?
For a facility this size, achieving an LT of 0.5 means aiming for less than 1 serious shift-stopping injury per 200,000 man-hours. That is a staggering, highly competitive goal in heavy industry. On the environmental side, a KPI might be something like a mandatory 10% annual greenhouse gas reduction.
That distinction is remarkable. Strategic KPIs set by the CEO, but daily safety execution, driven by the frontline worker. How difficult is it really to bridge that gap?
That is the ultimate challenge of management culture. And it's why Layer 2, the IMS itself, is structured around the classic PDCA cycle.
Plan to check act.
Exactly. This is the engine room. The plan stage requires comprehensive analysis, including SWOT, HZID, and a life cycle assessment, or LCA, which tracks the environmental impact of the rig from cradle to grave.
And when something goes wrong, the ACT phase of that cycle is what dictates the future, isn't it?
That's right. The ACT phase utilizes mandatory root cause analysis tools like the 5Y method and fishbone diagrams. This ensures that genuine systemic lessons are learned from every single incident, or crucially, every near miss.
You can't just treat the symptom.
You must fix the root cause. This is where continuous improvement is literally enforced by the system.
So moving from that strategic framework to the shop floor, this is where the safe system of work, or SOW, becomes the bedrock.
It is. The SOW is a structured procedural set of safety controls, ensuring that work is only performed when all safety conditions are physically verified and confirmed. It's a formal daily contract to be safe.
And the sources mention golden rules.
Yes. These are non-negotiable procedures, including the mandatory use of the permit to work system, or PTW, lockout, tagout for energy isolation, management of change, and strict fit for work requirements.
That permit to work system sounds like the linchpin. How complex does it get?
PTW is mandatory for all high-risk work. And it's not just one permit. It specifically requires separate, tailored permits for things like hot work, confined space entry, heavy lifting, and simultaneous operations, or SIMOPs.
SIMOPs.
That's where multiple complex activities overlap, which significantly multiplies the risk. And before any permit is issued, a specific job safety analysis, a JSA, must be completed and approved.
And connecting that JSA to the frontline workers, what are the mandatory daily requirements before a shift even begins?
Every job requires that JSA beforehand, detailing the task steps, hazards, and controls. And crucially, a mandatory toolbox talk, or TBT, has to be held before the shift starts.
What's the purpose of that?
The TBT is specifically designed to reinforce the JSA, especially right after an incident or if any site conditions like weather or equipment have changed.
Okay, so the core philosophy behind all these layers is the hierarchy of precautions. It's a required sequence of controls.
A foundational concept, yes. The hierarchy is always followed in sequence. First, elimination, then substitution of hazardous materials, then engineering controls like ventilation systems or machine interlocks.
And after that?
Then you add administrative controls like the PTW system and SOPs, and only then, as the very last line of defense, do you rely on personal protective equipment, or PPE.
It's an explicit rule, isn't it, that yards are not allowed to just skip to the end and hand out PPE.
Absolutely not. That level of procedural laziness is banned. PPE is the final barrier. It is never the primary solution to a systemic hazard. The source material is very clear. You must engineer the hazard out first.
What stands out to me are the incredibly specific, almost minute operational details that literally save lives. Take hot work. What are the non-negotiables there?
For hot work, they must conduct a gas test not once, but before and during the job. They have to mandate a fire watch for 30 to 60 minutes after the work officially stops because of the risk of delayed ignition.
Right.
And they must physically clear all flammable materials in a radius of at least 11 meters from the work site.
It's incredible how specific that is. And for something like confined space entry, which is just inherently dangerous.
Confined space is another SOW system. It requires its own permit, continuous gas testing, and a dedicated standby man outside who is constantly monitoring the entry point.
And if something goes wrong?
They must use forced ventilation, and a defined rescue plan has to be fully in place and approved before anyone even thinks about entering that space.
And finally, heavy lifting, which is a near constant operation.
Lifting operations require an approved, detailed lifting plan. They demand certified personnel, the operator, the rigger, and the signalman, and they must establish a strict exclusion zone.
Meaning no one under the load.
Absolutely no one under the load. Safety in this industry is entirely procedural, task-based management.
We've covered the S in EHS extensively. Let's quickly turn to the environment and the social contract, the ENS in ESG.
Right. The environmental goal is pollution prevention and building climate resilience. Air pollution control includes continuous stack monitoring for welding fumes, VOCs, and PM2.5 dust.
What about water?
For water management, facilities must use oil-water separators and strive for a zero-discharge policy where feasible, especially near coastal environments.
How do they manage the massive amount of waste and the facility's energy footprint?
Waste handling adheres to the strict waste hierarchy. Reduce, then reuse, then recycle, and only finally disposal. And there's a detailed mandatory plan for tracking and manifesting hazardous waste.
And energy.
For energy, they have to maintain a comprehensive carbon inventory, tracking scopes 1, 2, and 3 emissions.
Wait, can you define those scopes in the context of a fabrication yard?
Sure. Scope 1 is direct emissions from fuels burned on site, like in generators. Scope 2 is indirect emissions from the electricity they buy.
And scope 3 is the tricky one.
Scope 3 is everything else in the value chain. For a rig builder, this includes the massive carbon footprint of the steel and components they purchase and the logistics of transporting it all. It's a huge accounting challenge.
And the social contract, the CSR side, how does that extend beyond basic employment law?
CSR ensures compliance with international standards, specifically the ILO core conventions on human rights.
Oh.
It also dictates things like fair shift rotations for fatigue management.
How so?
While the sources mandated strict 14-day shift cycles, followed by a full week off to manage cumulative risks and reduce the chance of human error. It also requires visible support for local communities through healthcare, education, and local labor programs.
Lastly, governance and accountability. This loop brings us back to the investment community. Why is transparency so important?
Because to attract and maintain that ESG-focused capital, internal compliance just isn't enough. These companies use major global reporting standards like GRI, SSB, which is tailored specifically for oil and gas equipment and services, and TCFD for climate risk management. These reports are often released annually and frequently require independent third-party assurance to verify the data. That external scrutiny is the final layer of accountability.
So what does this all mean? The oil rig fabrication industry demands one of the highest, most complex standards of integrated management in the world.
Mm-hmm.
It requires compliance with a massive body of standards. The source material alone mentioned 42 types of required documents to ensure safety, sustainability, and competitive standing.
It's a system designed to mitigate disaster, not just respond to it.
That's the takeaway. The ultimate benefit of this entire complex integrated management system is not just compliance, but achieving operational excellence.
By eliminating waste, both material waste and, more importantly, the waste of human life, through reduced incidents and maximized efficiency, this entire expensive system ultimately drives down costs, increases efficiency, and creates true resilience.
And that leads us to our final provocative thought for you to consider. We noted that the documents state that successfully increasing the rate of near-miss reporting is documented as a positive KPI in these facilities.
Right, a positive one.
Given the high-stakes, high-risk nature of this industry, where the ultimate goal is zero fatalities, how can leaders successfully build the culture of trust needed to encourage workers to report failures and mistakes? Which takes more courage on the shop floor, reporting a near miss or pretending everything is fine?